The purpose of this video is to demonstrate how to use an eddy current slide rule, an eddy current calculator, to determine the F90 flaw detection frequency for plate and for tubing. And the F90 frequency is the frequency that will separate shallow near surface flaws and shallow far surface flaws by about 90 degrees for optimal detection. So I have two scenarios. The first one is going to be for plate. We're going to use 7075 T6 aluminum that's 30 mils thick. So to calculate the F90 using the slide rule calculator, it's a couple easy steps. If you look on the front, there's a standard depth of penetration scale here that moves horizontally across. What you're going to do is just take your red hairline and we're going to put that to 0.8 standard depths of penetration. So that puts 0.8 standard depth of penetration right at the back surface of your material. And then we use this little slide card in the middle to line up 0.8 with the thickness of our plate, which is 30 mils. We're going to line it right up there. So once I got 30 mils lined up with 0.8 standard depths of penetration, the last step is just to move the red hairline over to 7075 T6 aluminum. And then to determine the F90 frequency, I just follow the hairline down to the frequency scale here. And that red hairline shows up at about 16 kilohertz. So that's the F90 frequency for that material, 30 mils thick. Now the reason I use 0.8 standard depths of penetration, that's because the formula for plate establishes 0.8 standard depths of penetration at the back of your material. So it's not something that I came up with. It's based on a formula, and you can find that formula at eddycurrentcalculator.com. You can find the F90 formulas for plate and tubing. So the next example is going to be finding the F90 frequency for tubing, and we're going to use Inconel tubing that is 50 mils thick. So when we use 0.8 for plate standard depth of penetration, for tubing is a little different, formula is a little bit different. We're going to use 1.1 standard depth of penetration, and we're going to line that up with the tube wall thickness, which is 50 mils right there. So 1.1 lines up with 50 mils. And then again, you just move the red slider over to Inconel, and you follow that hairline down, and here you can see that the F90 frequency for 50 mil thick tube wall Inconel is about 190 kilohertz, somewhere right in there. So this is a very quick tool for determining F90 for plate and for tubing. You can find all the formulas that the slide rule is based on eddycurrentcalculator.com. You can also buy this eddy current calculator at eBay and Amazon. It's about 50 bucks. You just search for eddy current calculator. It's a very handy tool, save you a lot of time. Thanks.